Analyze and sketch the graphs of the following ellipse. 25x squared plus 16y squared plus 100x minus 96y is equal to 156. So what you want to do, you want to first complete the square so that you can find the equation of the ellipse in standard form. Okay? So what we want to do, we want to combine the x's together, right? So we want to put 25 and then x squared, and we want 100x, so we need plus 4x because that will be multiplied by 25 to give us 100x, right? So we're basically factoring 25x squared plus 100x together, like that. And then the same thing for the y, we're going to put 16 outside, and then we're going to have y squared. We need a minus 96y, so we need a minus 6y because this 6 is needed to multiply the 16 to give us 96. Okay, and that is equal to 156. Now further, now we can complete the square. We will have 25 x squared plus 4x. Now we need a half of this being squared, half of this coefficient, as you know in the process of completing the square. So 4 over 2 is 2. 2 squared is 4. Now this 4 wasn't there before, so we must subtract it. And the same thing in here. Y squared minus 6y. Now 1/2 of the negative 6 is negative 3. Square that, you get 9. And then subtract that 9 because it wasn't there before, is equal to 156. Now that's equal to 25. Now we're going to take the first 3 terms. We're going to take these 3 terms to give us a binomial that will be squared to give us the perfect square trinomial, right? So this is the perfect square trinomial that we're going to express as a binomial being squared. And that binomial is x plus 2 being squared. Because if you square this binomial, you will get these 3 terms of perfect square trinomial. Alright? And then same thing for this perfect square trinomial. This is the reason why we completed the square, because we made up a perfect square trinomial. And it will have its respective binomial that we're going to square in the same way that we did it for the x's. So now we're missing one term here. Minus 4 times 25 is minus 100. And then plus 16, and then the binomial being squared that will give us a perfect square trinomial is y minus 3 squared. Okay? This is equal to these 3 terms, the perfect square trinomial. And now we're missing 16 and 9. 16 times 9 is 144. There's a minus sign, so it's minus 144 is equal to 156. Okay, so what we have as a result is 25 times x plus 2 squared plus 16 times y minus 3 being squared. And then we're going to basically add 100 on both sides and add 144 on both sides, right? So 100 and 144. And that should give us the number which is equal to 400 on the right side. Okay, so now that we get 400, we're going to divide both sides by that 400, because we know in the standard form of expressing the ellipse, we have the right side being equal to 1, right? So we need to divide both sides by 400 so that the right side is 1, which is what we want. So then divide both sides by 400. What happens is 400 divided by 25, you reduce this fraction, okay, you're going to get 16. So as a result, what we have is what we need, x plus 2 squared over 16 plus 400 divided by 16 is going to be precisely 25. And that's what we need. So y minus 3 squared over 25 is equal to 1. Bingo. So this is now in standard form. you know, based on the fact that this is 2 and this is -3, the center is going to be at -2, 3. And how do I know that? Because we know the top should be expressed x minus h squared plus y minus k being squared, okay, is equal to 1. And I'm not going to discuss the a and b yet because a and b vary. The placements can vary. Sometimes the a is under the y, sometimes the a under the x, right? So I'm not going to put that down. But I want you to see that -h is equal to +2. If -h is equal to +2, that means h is equal to -2, right? This is the center. Okay, so this is h, this is k. And the same thing for the k. -k is equal to, we're just matching that, -k is equal to -3. So that means k is equal to +3. If you divide both sides by -1, you solve for k. And that's precisely what we have. Right, so the center is -2, 3. So let's put that center down as a reference point. So -2, 3. So -2 from the origin and then 3 up, right? So this is the center. So now what happens? So when we're talking about a and b, we know a must be greater than b and a must be greater than c. Okay? So let's put that down. We know that a must be greater than b and a must be greater than c. Okay, and I'm going to put the c with this color. A must be greater than c. Okay, so a is greater than b and a is greater than c. Now we know that in these two, underneath the x's and the y's here, we have the a and the b. We know since a must be greater than b, then a squared must be equal to equal to 25, right? Because we know that the bottom will be squared, not just the letter, but the letter being squared. Right, so a squared in this case is 25. So let's put that down. A squared is equal to 25, which means that a, if you square root both sides, a will be equal to, now a must be positive, remember that, that's why plus minus is not applicable. A is equal to 5. Okay, so a is equal to 5. Now b squared is equal to 16, as we just said, right? This is equal to the b squared. That means that b is the square root of that and only the positive square root. So b is equal to 4. Okay, so b is equal to 4. Now c, how do we find the c though? We use the equation a squared is equal to b squared plus c squared. B squared plus c squared. B squared plus c squared. Now, it might look similar to the Pythagorean theorem, but it's not exactly this one, because in the Pythagorean theorem you had the different arrangement of these three letters. It was c squared is equal to a squared plus b squared, right? So here's a squared is equal to b squared plus c squared. But the good news is that when it comes to hyperbola, and you're going to see that in my other videos and in the next videos, in the hyperbola versions, the equation will be the same exact arrangement as the Pythagorean theorem. For the hyperbola, it's going to be c squared is equal to a squared plus b squared. But for the ellipse, unfortunately, it's going to be a different order. It's going to be a squared is equal to b squared plus c squared. And as you can see, it makes a lot of sense, because a must be greater than b and a must be greater than c. Okay? So now that we've found this equation, we can solve for c, right? We can substitute in the numbers for a and b and solve for c squared. So let's use that equation. So if we use that, we're going to have 5 squared because that's the a value. So 5 squared is equal to the b squared, which is, now let's put 25. I mean, might as well do that. So a squared is 25. So let's put 25 is equal to 16 plus c squared. C squared. So that means if c squared is by itself, we can solve for it, which is great. So c squared is what? You're going to basically subtract 16 on both sides. So c squared is equal to 9, right? Because you subtract 16 on both sides, you isolate your c squared. C squared is equal to 9, which means that the c value is 3, right? So c is 3. So as you can see, it makes sense now that a is greater than b and a is greater than c, right? A value was 5, b value was 4, c value is 3. So now, even if you try to memorize stuff and you forget how to do this, just set your x value to be -2. If you set your x value to be -2, this whole thing will turn into a 0, because 0 is going to be on the top. 0 divided by 16 is still 0. That means y can be solved for. So when x is equal to -2, you solve for y. So let's see. So when x is equal to -2, what happens? We get y minus 3 squared is going to be equal to 25. All right, so that's what we're going to get. So that means when 1 minus 3 is equal to 25, 1 minus 3 is equal to plus minus 5, right? Because you square root both sides, you get rid of the square, and you square root the right side. Don't forget the plus minus in this case. So as a result, y can be two things. You add 3 on both sides. So y can be two things. 5 plus 3 is 8, or -5 plus 3 is going to be -2. Right? So when x is equal to -2, you will have 2 points. Okay? So 8, 4, 5, 6, 7, 8, 1 point. And the second point is -2. Right? So it's going to be here. And as you can see, what we see here is the distance of 5. And that's exactly the value of a. So a, you add the value of a to the center that we have here, and you also subtract the value of a from the center to get this vertex. Now these are the vertices on the major axis. Okay, these are the vertices on the major axis of this ellipse. Now in the same way, when you set the y value of 3, this whole thing turns into 0, and x can be solved for. Right? Let's check that. So when y is equal to 3, what happens? X plus 2 squared is going to be equal to 16, basically, right? Because this thing is gone. 1 times 16 is 16. You get rid of this fraction. This is what you get. That means x plus 2, I'm going to not use parentheses this time, x plus 2 is equal to plus minus 4, right? Because you square root both sides, plus minus on the right, square root of 16 is 4. So there are two x values possible, right? If you subtract x on both sides, you will have two different x values, right? The first one is plus 4 minus 2. That's going to be 2. And the second one is minus 4 minus 2, which is minus 6, right? So let's find those points. So y is 3, so 1, 2, 3. Oh, well, let's start with the x's first. 2 and, let's see, x is 2. 1, 2, and y is 3, right? So 2 and 3, bingo. And then x is minus 6, so let's go left. 1, 2, 3, 4, 5, 6. And the same y value, of course, which is 3, right? Because we tested the same y value to give us two different x values. So as you can see, these are the co-vertices, which determine the minor axis, right? The minor axis. And why minor? You can see the distance from the center is 4. whereas the major axis vertices here, the distance was 5 from the center, right? So you can see definitely there's a greater distance here. That's why this is a major axis and this is the minor axis. Right, so these are the co-vertices that we found using algebra. And now we need to find the Foci. So as you can see, the A values are used to find the vertices. The B values are used to find the co-vertices, right? You can see the B value is 4. And the B value is the X value, obviously, whereas the A value was the Y value, right? And you can see something really beautiful here. You can see that the X values correspond to the B value being underneath them, right? Because we said that the B value was the X values that we add or subtract from the X value of the center, whereas the Y values are the A values. And it makes sense, right? Because the A squared is 25, and that's underneath the Y's here, right? So there's a correlation actually. But if you forget that, you can always use algebra the way I showed you here, and you will find the co-vertices and the vertices successfully, right? So in this case, the Foci, the letter responsible for Foci is going to be the C. The C is the smallest value here in this case. So the C value is going to be responsible for the Foci that we defined. And this will be the Y value that you add or subtract from the center, from the Y value of the center, right? The Y value of the center is 3, right? So Foci at, so the X value in this case is -2, right? Because the Foci will be on the major axis, not on the minor axis, but on the major axis. So the X value should be the same as the center, so -2. And then let's see, and then we're going to have 3, the center Y value, plus C. So I'm just going to do plus minus C. So you can see we can kill 2 birds with 1 stone. So plus minus C. All right, so that's going to be like that. So what is that going to be? That's going to be -2, and 3 plus 3 is 6, and -2, 3 minus 3 is 0. So let's find those points. These are the Foci that we found. -2, 6. 1, 2, 3, 4, 5, 6. Beautiful. It's right here. And then -2, 0. Very good. That's here. So as you can see, the distance to the Foci should be absolutely the same. It should be 3 and 3. Okay? So, and let's find the other information. So co-vertices at -2, -4. Now be sure that you've put the X value first and then the Y value. So no, the X value. So -2, -4, right? To give us -6 for the X value. -2, -4. And then the Y value is 3, right? That doesn't change. And then -2 plus 4, same Y value. So that gives us what? That gives us -6, 3 and 2, 3. Let's compare that. -6, 3. That's beautiful. That's a co-vertex. And 2, 3. 2, 3. That's exactly what we have. So we found the Foci and co-vertices. And finally, let's find the vertices algebraically. So the vertices are on the major axis. So we have to take the center X value, that doesn't change, but the Y value will, right? So 3, the center, plus 4, plus the A value, plus 4, and then subtracting the A value from the center Y value, 3 minus 4, right? So that should give us -2, and then
sorry, the a value was 5, not 4. Why did I put 4 here? It should be 5. Minus 2 plus 5. And 3 plus 5, 3 minus 5, so that's minus 2, 8. And minus 2, minus 2. Let's confirm that. Minus 2, 8, 4, 5, 6, 7, 8. Beautiful. And minus 2, minus 2. Good. So these are the vertices. So just in case if you wondered, what we did was we added the a. Well, let me use the same color I used, the blue one. That's the a value, the 5, and we subtracted the a. And here we subtracted the b and added the b to give us the co-vertices. And here, of course, we added and subtracted the c to find the Foci. All right, so these are the key features of this ellipse, and we can try to connect it to make sense of it. It's not going to be the best picture, but you're going to see that this ellipse looks something like this. Okay, the center is here. These are the Foci. So these are the Foci. So we can mark it F. These are the Foci. So I hope this was useful. Thanks so much for watching. See you in the next video.